Hi everyone, welcome to Siva Science Galaxy. In this video, I will be discussing about aromatic compounds. What are aromatic compounds? Aromatic compounds are organic compounds depicting the following structural features. Aromatic compounds are cyclic and planar in nature. Each ring atom of aromatic compounds has a p orbital parallel to one another in order to have continuous overlap for delocalization of pi electrons. The number of pi electrons of aromatic compounds is equal to 4n plus 2, wherein n is a whole number. It can be 0, 1, 2, 3 and so on. This rule can be called as Haeckel rule. Let us discuss about few organic compounds. I have drawn here the structures of cyclohexatriene and cyclobutadiene. Is cyclohexatriene an aromatic compound? Let us discuss about the structural features of the compound. First, the cyclohexatriene is a cyclic compound and planar in nature. Each carbon ring atoms of cyclohexatriene has a p orbital which are parallel to one another. The cyclohexatriene has 3 double bonds, so there are 6 pi electrons. So the cyclohexatriene fulfill the Haeckel rules, 4n plus 2, wherein n is equal to 1. So the cyclohexatriene is an aromatic compound. Let us discuss about cyclobutadiene. The cyclobutadiene is a cyclic compound and planar in nature. Each carbon ring atom has a p orbital which are parallel to one another, and it has 2 double bonds, so number of pi electrons is 4. So it cannot fulfill the Haeckel rule. So cyclobutadiene is not fulfilling the Haeckel rule. So cyclobutadiene is not an aromatic compound. Herein I have drawn structures of 2 organic compounds, cycloheptatriene and cyclooctatetrene. Let us discuss about whether the compounds are aromatic or not. First, let us consider cycloheptatriene. The cycloheptatriene is a cyclic compound and planar in nature. The cycloheptatriene has 3 double bonds, so number of pi electrons is 6. So it fulfills the Haeckel rule. However, this compound is not an aromatic compound. See, the structure has 7 carbon atoms. Of the 7 carbon atoms, 6 carbon atoms, 1, 2, 3, 4, 5, 6. These 6 carbon atoms have p orbital which are parallel to one another. This carbon atom is saturated. So this compound is not an aromatic compound. Now let us discuss about the cyclooctatetrene. As you can see, the cyclooctatetrene is a cyclic compound. However, the compound is not in planar in nature. The overall shape of the compound is cup shaped. So it is not a planar compound. And it has 4 double bonds. So number of pi electrons is 8. So not fulfilling the Haeckel rule. So this compound is not an aromatic compound. Now let us discuss about naphthalene. Is naphthalene aromatic compound? Yes, naphthalene is an aromatic compound because it is cyclic compound and planar in nature. It has 5 double bonds, so number of pi electrons is 10, fulfill the Haeckel rule, and each carbon atom in the ring has pi bond which are parallel to one another. So naphthalene is an aromatic compound. Now let us talk about aromaticity of pyrrole and furan. Both pyrrole and furan belong to heterocyclic compound. First, let us discuss about the aromaticity of pyrrole. Pyrrole is a cyclic and planar compound. It has, as you can see, 2 double bonds. So number of pi electron is 4. So look at the nitrogen. The nitrogen atom in pyrrole has unshared electron pair. The unshared electron pair is in the p orbital of nitrogen. The p orbital is parallel to the p orbitals of ring carbon atoms of pyrrole ring. So the nitrogen has unshared pair electron. So you can add 4 plus 2 is equal to 6. So there are 6 delocalization electron in the case of pyrrole. So the pyrrole fulfill the Haeckel rule. Haeckel rule 4n plus 2. So the pyrrole is an aromatic compound. Now let us talk about aromaticity of furan. The furan is a cyclic and planar structure. It has two double bonds, so number of pi electron is 4. Now look at the structure of furan. It has an oxygen atom. The oxygen atom has two unshared electron pair. So the two unshared electron pair are in two different p orbital of oxygen. One of them is parallel to the p orbitals of ring carbon atom. Another p orbital is perpendicular to the p orbitals of the ring carbon atoms. So the number of delocalization electron in furan is 4 plus 2 is equal to 6. So the furan fulfills the Haeckel rule. So the furan is an aromatic compound. Now let us consider, instead of oxygen, if you have sulfur over here, then the compound can be called as thiophene. The thiophene is an aromatic compound. So the logic we discussed for the furan is also applicable for thiophene. So thiophene is an aromatic compound. Now let us discuss about aromaticity of pyridine. Very interesting molecule. Look at the structure of pyridine. It has 3 double bonds and 1 nitrogen atom. The nitrogen atom has an unshared electron pair. Now let us discuss about whether the compound is aromatic or not. First, the compound is cyclic and planar in nature. Each ring atom has p orbital which are parallel to one another. Now number of double bonds in the pyridine is 3. So number of pi electrons is equal to 6 for pyridine. Now what about the unshared electron pair on the nitrogen atom? The nitrogen has unshared electron pair. The p orbital containing that unshared electron pair is perpendicular to the p orbitals of the ring atoms in the pyridine. So that unshared pair electron cannot be considered as the delocalization electrons in pyridine. So the number of delocalization pi electron in pyridine is 6. It fulfills the Haeckel rule. So the pyridine is an aromatic compound. I hope you understood the concept of aromatic compounds. Thank you very much for watching the video.